Good morning, students. In the previous class, we have discussed Wheatstone bridge, and I gave you condition for the expression for the condition of balanced Wheatstone bridge. And a Wheatstone bridge applications, one of the application is meter bridge. This is important for problems, and it is important. They don't ask the explanation of the experiment, etc. But you have practical examination of this. So you will be doing the experiment practical in the lab using these methods. Knowing theory is very important. If I have questions in the practical examination, they will ask you to the theory points. And meter bridge. Why it is called meter bridge is because it contains a wire of 1 meter length. Wire of 1 meter length is there, so it is called a meter bridge. One thing. Second, principle. It was the principle of Wheatstone bridge. It was the principle of Wheatstone bridge. What is the uses? Meter bridge is used to find the unknown resistance of the resistance value. Unknown resistance. If you have unknown resistance, you can say unknown resistance value also. And resistivity of the metal or the wire. Wire will be given, and that wire material resistivity you can find out. Hence, by knowing the resistivity is constant of the given material. Pure metal, if you have taken means the rho is resistivity is constant. It will indicate the purity of the material. Impurities means resistivity change. So nichrome, it is nichrome, that is impurity of alloys. Nichrome resistivity is different. Copper resistivity is different. By knowing the resistivity, we can find out the nature of the metal also. Okay, or manganese or nichrome, what metal you are using, you can find out just by finding the resistivity, we can find out the value of nature of the metal also. Next is construction working. It contains thick metal strips, thick copper strips. Copper or brass can be used. Sometimes you find that devices of the laboratory steel, but this is not steel. The nickel coating will be there on the surface of the copper or brass. It looks like a steel, but actually inside that is supposed to be a good conductor of electricity. So thickness, more thickness means what is the resistance is negligible. Thick strips are used means resistance is negligible. We should not consider the much resistance of these strips. These strips are taken like this U shape, but here it has a brakes. This left side brake is called as the left gap, right side brake is called as a right gap. In the left gap we fix the resistance, which is we don't know. The resistance will be given to you in the laboratory. The wire will be given. This can be a nichrome or manganese or steel. Generally we use this nichrome or manganese. So this wire is taken the plastic pipe in the like a coil. Okay, but coil symbol is actually taken. This is a symbol of the coil called as inductance, but don't take this in the diagram. You have to consider the resistance only. Resistance symbol is sharp like this, not loop like this. Okay, this is the unknown resistance. We don't know what the value of this resistance, that we have to find out. And its length of this wire will be given to you. Length of the wire will be given. If you expand it, no length will be given. Before winding only, the length will be told to you. This may be around 1 meter length, but by taking the coil, length will happen to be decreasing. Maybe 70 centimeters or 1 meter length, like that will be there. And this wire, two terminals are there. These two terminals will connect from these two ends in the gap like this. This unknown resistance will connect like this. Okay, and known resistance connected in the right gap. Left gap or right gap. Right gap of the thick strips, known resistance is connected. Known resistance is taken in the resistance box. We are having the resistance boxes. Already I discussed about resistance box. It contains several resistors inside connected between the blocks. These are the brass blocks of negligible resistance, very thick weight there. Connection you have to do between these two terminals. Screws are there. You have to take a wire connected between these and these connecting wires. You must prefer the more thick wire of less resistance always. More thickness, less resistance. There is a PVC coating will be there. You have to cut off the coating at the edge, and you will be given like this in the laboratory. Students will don't have to do it. And in the screw, you have to fold this wire connection part, not plastic part, and tighten the screw. Fold it in the direction of the rotation so that it will not be present. And pull it up, it will be strong. Connection is done here, and one more connection is done to this screw. So these two connections are connected here. With these two terminals from here to here. Inside the box, all the resistors are in series. All the resistors are series. Between the gaps, these two blocks gaps, resistance written as 1 ohm. 1 ohm written means if you remove this key, not putting key resistance is 0. If you remove the key, resistance is what value written, that value you have to count. 1 ohm. If you remove next one, this is 2 ohms written here. That means if you remove 2, all are in series added. 1 plus 2 added. 1 plus 2 is 3. If I want like a 7 I want, and remove the 5. This 5 plus 2 plus 1, 8 it is. I want 7, so only you close. 2 and 5, total resistance will be 7. Okay, this is a small box, another one bigger box is there, in that infinity also there. Don't use that infinity. Infinity means open circuit, current will not be there. So this is a known resistance called as standard resistance. Inside the resistors are made of the wire of the manganese or nichrome. Wire is used. Why that is preferred is because of the low temperature coefficient. Even if while passing the current, the wire is weak and its resistance changes, it should not change. When it should not change means you have to prefer the material with a low temperature coefficient alpha. Low alpha is there means the resistance remains constant. Resistance remains constant with the change of temperature. For the proposed preferred material called nichrome, manganese or constant. So we generally use this nichrome or manganese. Manganese is best preferred compared to other materials. So this is resistance box. Known resistance R ohms. How much you are removing from that? How many keys? What number you are removing? That is known value. This is known value. You can keep this here. Next right side also doesn't matter. You can keep this here also. Okay. Anyway, exponent value you can connect it left to right, or exchange into multiple lines. You can keep it very easy. In the middle of this, you take the galvanometer. Galvanometer is a device used to detect the current. The galvanometer has a 0 set. This galvanometer is actually somebody moved this needle. This galvanometer needle will be there. Initially, when current is not passing, it should show 0 degree. In center will be there. When current is passed from right side, this side it is passing means needle will bend that side. If the current is passing this side means needle will bend that side. If no current passing means needle will be the center showing the 0 readings. Okay, it will not measure the value of the current how much it is. It simply says that more current, less current, or current is there or not, whatever we can detect. So this is connected from the center terminal. Connections are done here. This wire in the center of the screw here. Okay, and other terminal connected to the thick metal rod nail. This is made of brass inside, nickel coating is on the top. Sharp edge is there. This is called as a jogging. This is called as a jogging. J is a jogging. Okay, and this is why it is called jockey. From center terminal to galvanometer to jockey. Jockey can be moved on this 1 meter wire. From here to here, wire is there. That one wire length is 1 meter, so it is called a meter bridge. And between the terminals A and B, length of the wire is 1 meter, and the A and B terminals are connected to the battery of standard battery of like equivalent resistor, whatever doesn't matter. There is battery box and then key. Generally, you will be given sometimes the batteries are used. Okay, or else we use the battery eliminator. Eliminator means eliminates the battery cells. Instead of the battery cells using, quickly they are costly. So we use the AC to the AC power supply converted to DC voltage, and you can choose the voltage you want with the help of this battery box. Connect this to the 230 volts, and output you are taking from here. These two screws terminals, plus means red, minus means black. From here you will make the connections from the wire and connect to A and B. Doesn't matter which is plus, which is minus, doesn't matter. Okay, you can connect. Generally we take the diagrams left face, right side minus, not face. And you can choose the voltage here, 2 volts, 4 volts like that. You can choose the voltage. Generally preferred is low voltage, not high voltage. Low current, low voltage. And that power supply output is not shocking you. Inside in 230 volts is dangerous, but outside is this 224 volts does not. Up to 40 volts you will not get electric shock. So we can handle it directly with bare hands. This is 1 meter wire, and this is a metal bridge. This is a metal bridge. This is a left gap. This is a brass strips given, and this is center connected point. This is a right gap. You have to see from the metal this scale towards you. Keep the scale towards you. That means you have to see it like this. When you are seeing it like this, this is a left gap, right gap. Scale towards you should keep. And from left terminal to right terminal, you have to connect the battery along with the key. Key I didn't bring. I will show you the function of the key later. Also required in the next experiment. Key. If you remove this key, current won't pass. You put the key, plug key just like a metal bit with this resistance box. You put a key, the thick one, then current passes. It is like this. This is a thick copper nail key we call. And if you insert in the gap, the current passes. If you remove, current will not pass. So switch on and switch off power supply, we take care of this point. It's called a plug key. And these are metal bridge. This wire, 1 meter wire is there on the scale. Sometimes the scale will be on the side of this meter wire also. In this device, newly supplied ones, we have the wire directly on this scale, 1 meter scale. And this wire is made of what metal is? Nichrome, manganese or constant is preferred for making this wire also. In all electrical devices, standard resistance required means resistance should be constant, means that should be made of either nichrome, manganese or constant. Remember the names. This is a meter wire you can see on this scale. Okay. Next we will come back to this diagram. This is a construction. You can write construction but separately, but till now they didn't ask the explanation of the operators. Required for the examination, practicals, Another thing is, but problems of course it is very important. We keep the unknown resistance left gap or known resistance right gap, and current or power supply between A and B. How to check up the connection of current or not? To check up the connection of current or not, what I do is current is jockey to the left side terminal A and not right to the points here. Current jockey to the A. When you connect the jockey to the A, then the difference in the galvanometer should be one side completely. This is 0, but needle should be exactly to the left side. If you touch the jockey to the right side B, when you touch the jockey here, jockey touch it here, and these wires are flexible place. You can move to any side. And jockey wire must be very longer because we have to move this jockey to the left to right by 1 meter length. So this wire length should be very large compared to other connecting wires. And jockey touch it to the right side at point B, then difference should be right side. Left touching, left deflection, right touching, right deflection is connections are correct. Sometimes if you touch left side, you get completely right side deflection. Okay, and then you must get it touching here, it should be completely left side. That is also connection correct only. Okay, if you want to get the same direction of deflection, just interchange the connections here or direct connections. If you interchange, you will get the deflections in the same direction you want. Left touching, left deflection, right touching, right deflection, or left touching, right deflection, right touching, left deflection is also correct. If both sides touch it, left deflection only is there equals 0, means side of the 0 means wrong connection. Somewhere loose connection is there, you have to verify the connections. Okay. And it works on the principle of Wheatstone bridge. Principle is important for one question. But Wheatstone bridge contains how many resistors? When not balanced, 5 resistors. When balanced, 4 resistors we take. Okay. PQ in the Wheatstone bridge. PQ RS. So where is RS means when you touch the jockey on this wire, it's called jockey. Jockey is actually name of the horse rider. Horse rider, when the horse will go like this, like on the bike. Horse will be, when the horse is galloping, no, the person will be moving up and downwards. So that's why it's called jockey. The jockey here, metal will also not drag like this. It should be touched like this at different points. You should not drag it. You have to touch at different points. What is the reason of touching here is this wire AB, the area of crossing should not change. It should be constant. It should be constant. Then you have to, if you drag it, the sharp nail will scratch the wire. This is a galvanometer, and jockey touch it here like this at different points. If you drag it, what happens? It will scratch the wire. When it scratches the wire material is gone out, means what are pressed hard also, area cross section changes. It should not change. Why? Because for this wire we are going to use the resistance R equal to rho into L by A relationship. R equal to rho into L by A. So here resistivity, same metal A to B, same resistivity. A should be constant. Then only we can say R is proportional to length. That condition we want means area should be constant. Rho is anyway constant, same material. So to keep this area constant, you should not scratch the material. You must touch only gently, not pressing hard also. You touch it at different points until you get a zero deflection galvanometer. And so zero deflection galvanometer we have now. This G is one resistance. 1, 2, 3. Okay. Now this should not be counted when current is not passing through. The galvanometer is showing zero deflection means Ig is 0. Next, this wire resistance. This wire resistance is R1. This wire resistance is R1. R1 and R2 we have to take the consideration. R1 is R2 relation is L1 by L2. This length R is proportional to L. So R1 is proportional to this length, R2 is proportional to this length. Total length is how much? 100 centimeters or 1 meter. You have to be careful with this point also. They make you 1 meter means don't take 100 minus you take. This L meter should be 100 minus L in centimeters. If it is given in meters means 1 minus L only take in meters. That you have to be careful with that. Okay. Next, better take in converting in centimeters. These are converted centimeters, these are converted centimeters. It may be easy. So here this resistance proportional to this length is resistance proportional to 100 minus L in centimeters. Then R is proportional to L is considered only when the area of cross section is constant. Therefore we take R1 is equals to rho into L1. L1 means L by A. This R2 is rho into L by A. This L is 100 minus L2. Then we require balance condition. Balance condition which is what? When galvanometer shows zero deflection means current Ig is 0. Ratio of the resistances. Right top equal to bottom or left side resistance equal to right side resistance. That means x by r supposed to be equal to r1 by r2 or x by r1 equal to r by r2. These one understand. So they will ask you in the examination, show me the comparing the Wheatstone bridge, where are the 5 resistors or 4 resistors? 1, 2, 3, 4. That you have to show. Okay, but we don't take r resistance of this one. What we take is the length only because r is proportional to L. So here A is constant, we have to take When you take A constant, rho is also constant. Therefore, R1 by R2 is equals to L1 L by 100 minus L is the relationship. So what balance condition? When the bridge is balanced, when bridge is balanced. Balance means what happens? Galvanometer reading is 0. Galvanometer reading is 0. In that case, left x by r is supposed to be equal to R1 by R2. But R1 by R2 is nothing but equal to L by 100 minus L. This is equal to L by 100 minus L. We have to find out unknown resistance. Therefore, x is equals to R into L by L by 100 minus L into R. This is the resistance. Unknown resistance you have to find out. This is very easy to find out. But one more thing adjustment is correct readings if you want to get in this experiment. Left resistance, right resistance should be nearly equal. In the beginning also, if the x value of unknown resistance you have to adjust such that, for example, this is 2 ohms. Don't take here 100 ohms and 200 ohms, you should not take in the boxes. You should not take 110, 10 also. 2 ohms, here you take 1, 2, 3, 4 ohms. How do we know that is? If the x is equals to r, left gap resistance is equal to right gap resistance, automatically left length will be equal to right length. That means if this is a 2 ohms, this is also 2 ohms, then balancing is over 100 centimeters. Balancing point will be at 50 centimeters. So the 50 centimeters point is a 50 centimeters. So you have to adjust this right side resistance such that you will be getting the balancing point around 50 centimeters. Not this corner, not this corner. Why? Because the bridging balancing condition you have to take. Balancing condition is equal to B by equal to R by S relationship. This is equal to this one. But what about these materials? They should have the negligible resistance. In case, if I take here 100 ohms, but here the resistance is say only 2 ohms, then balancing point is not sufficient within this length. Then what happens here is even this balancing point may go, this side resistance is more, means length is more resistance, more length is. This resistance more means this length will be more. If the x increases, this by this ratio should be constant. Okay. See, the left resistance increases, no, left length also increases. Right resistance increases, no, right length increases. If left equal to right means 50 centimeters, exactly my point. So here, if for example, this 100, this 2 ohms, then balancing point will not be within this 1 meter length. You may get it here also. You may get it here also. This is a negligible resistance, not zero actually. Negligible resistance also comes into picture now, and that need to be considered if the resistance is very high in one gap compared to the other gaps. So that balancing point within the 1 meter length only if you want to get that, then in that cases you should not take very high resistance in the gaps. Okay, right side gap, left side gap should be resistance should be nearly equal to get the correct readings for us. Thick wires, why thick strips are used? Thick strips are used so that their resistance is negligible. Zero will not be there. Zero resistance is possible only for the superconductors. Superconductors are possible, conductivity is possible only for the alloys close to absolute zero. Below 72 kelvins, negative temperatures will get very low temperature. That is practically not, we don't take here. So we don't take the resistance zero, it is a negligible resistance, very low resistance we say. So to negligible resistance compared to the resistance you are using here. So resistance should be considered only for these values, not for the strips, not for the connecting wires. For that purpose, we are doing the thick strips or thick connecting wires to minimize the resistance of those materials. And you have to consider only the resistance, the gaps only will be automatically considered. So unknown resistance, we know this is known resistance, so we know balance means we can find out the unknown resistance using this formula. So this is unknown resistance. Unknown resistance in terms of known resistance. Next is this one application. So I am not finding unknown resistance. Thick copper wires, strips, copper or brass wires, strips. We don't use the wires of the brass, we use the copper wires only. But strips made of the brass, strips has thick copper wires or brass have negligible resistance. Next thing is left gap, right gap resistance should be nearly equal. These are the important precautions, but you will not be asked right, but you must need to know it. Right? Yeah. Resistances must be nearly equal. Nearly equal. Next is high resistance box. HR is used in series to galvanometer. If condition is always required, but draw it. Only if the galvanometer deflection is very high, the large current passes on, deflection is before setting for the zero. The deflection is very high means that needle may go outside the galvanometer scale, that may damage. To protect the galvanometer from large currents. Used in series to galvanometer to protect it from large currents. High resistance box HR. High resistance box HR is used in series to galvanometer to protect it from large currents. Here sometimes if it is deflection is going beyond the limit of this galvanometer, you can hear that needle touching the edges and it may bend also if it touches fast. So the galvanometer may damage. To protect it from large currents, high resistance box is used. One box will be given to you. It is called as the HR, high resistance box. But not compulsory using it, because most of the time, if you want to reduce the current here, this battery voltage you take less voltage. Automatically deflection will be less. If you take large voltage current, problem comes. Otherwise, no problem. So generally, we don't take it in case, but you must know the precautions. These are the important precautions you know. Next is jockey must not be dragged. It must be only touched at different points. Jockey must not be dragged but touched at different points on 1 meter wire, that is AB. On this 1 meter wire you will touch at different points. And what is this 1 meter wire made of? Is manganese, nichrome or constant is preferred in making. These are the points related to finding the unknown resistance. Next equation I will give for resistivity. Next is to find the resistivity of this unknown material. To find the resistivity of the unknown material, that will be given as a wire, this one. So X is a wire, X is resistance of wire of length. Different symbol we take as L1 we take it. Because L is a balance length you have taken, we take this as a L1. Rho may be given or S may be given for the specific resistance or resistivity. This is resistivity of wire, that is X, unknown resistance value. Okay, and this is R instead of the known resistance R, they may give a standard resistance. This also may be given symbol with S. Carefully done. This may be given symbol S. Specific resistance R sometimes it has S. Which one is what you are using? You have to be careful. This is resistance. What is the formula for resistivity? Is rho equal to R equal to rho into L by A. So R is nothing but equal to X. R equal to rho into unknown resistance equal to, but rho unknown resistance first you are finding it. So we know X value, we know it now. Unknown resistance value, we know it. Yeah, R equal to rho, unknown resistance equal to rho into that length by A. A is area of cross section. A equal to pi r square. That is area of cross section of given wire. R is radius. Radius you will find with the help of the screw gauge, but you will be given in the examination. In the examination, they will give the value of R, they will give the value of L1. L1 and R will be given smaller. Find the area of cross section and find the x value by this previous method, and then you have to find out rho. So rho is equals to x into A by L1. Oh, meters is the answer you have to find out. X known unknown resistance you found out before. A equal to pi r square you find out. And L1 will be given, smaller also will be given to you. This is the radius of the wire and find out the resistivity. This is the wire. This is the wire. Okay, nichrome or manganese will be used. This wire is taken in the plastic pipe. Maybe it may not be in plastic pipe also. So, but wire gap should not be touched. If I take this wire as a coil, like this. If I pass the current through it, plastic coating is there. Because the plastic coating is there, if they are touching directly, current do not pass from one turn to other turn directly, don't go. It has to pass through the length only. So here, but this wire don't have the plastic covering. It will not be there. Here in this case, you are given with the plastic pipe on this tape is kept insulation tape such that they don't touch each other. So current, if they touch, current directly passes from one turn to other turn, not a length of the wire. Current should pass through length of the wire, then only you can consider its total length. If all taken like this and there is no plastic covering, PVC covering is not there, if you take the wire like this, then this wire resistance won't be counted. It comes to be 0 or negligible resistance because current directly passes here, not along the length. Total length, even if you take also not considered because when touch without plastic covering, if they touch like this wire, if it touches directly current passes, not along the length. So current always prefers the low resistance path. If you are touching here, then don't go along this. Okay. So for this wire, if it is not plastic pipe is not given, the wire make sure that the terms what you are taking should have a gap in between, so that you can find the total length of this wire as L1. In the examination, they will give you this length and they will give the radius. If not given radius, with the help of the screw gauge, you have to find the radius. How to find out, you must know it. Find the radius with the help of the screw gauge and find out the area of cross section. Then find the resistivity by this method. This is the method prediction. Did I mention that left gap radius must be nearly equal? This is the important condition you need to know. And if x equal to r condition, what happens? If left gap resistance x is equals to right gap resistance r, then what is the value? 50 centimeters, exactly midpoint units. That is the initial checking of condition you have to take up. And the points I told you already. If touch the left side, jockey touch the left side at A, deflection should be left side. If touch the right side, deflection should be right side. That initial conditions. If jockey is touched at A, left end, then deflection must be deflection in G must be to left of 0. Similarly, if touch right side, right of 0. And this is not there for me. If jockey is touched left end of 1 meter wire, then deflection in G must be to the left of 0. Next is if J means jockey is touched to right end B, then deflection in G must be to the right